When the Arctic ice melts completely, will the sea level rise or not? The answer is quite simple. No or yes, but to a negligible extent, similar to any other regular ice. The Arctic ice and floating icebergs also melt when the weather is warmer, but this phenomenon hardly contributes to the global sea level rise. The reason is simple: they are already in the water. Hello, it's nice to meet you again in a new Enigma video. According to Archimedes' principle, any object submerged entirely or partially in a fluid will be buoyed up by a force equal to the weight of the fluid displaced. This means that the volume of water and sea ice occupies almost the same volume as the water it contributes to the ocean when it melts. As a result, the sea level hardly rises when the ice on the sea melts. Although the difference in density between saltwater and freshwater leads to a difference in volume between the saltwater occupied by the ice and the freshwater resulting from the melting ice, the change is so small that it can be entirely ignored. In case you are not convinced yet, the seawater near the surface has a specific gravity of about 1027 kg/m3, while 1 cubic meter of freshwater only has 997 kilograms. The difference here is only 3%, which means that a floating ice block made of freshwater will occupy less than 3% of the volume contributed by the melted ice compared to the volume of the sea. In the Northern Hemisphere, in April 2023, the volume of the Arctic sea ice was about 23,100 km3. A 3% density difference corresponds to 693 km3 of additional water poured into the oceans, equivalent to 1 billion cubic meters per kilometer of difference. To make it easier for you to visualize, it may sound alarming until you realize that the oceans cover approximately 361 out of the total 510 million square kilometers of the planet's surface. Assuming Earth's oceans are a perfectly flat water mass, the melting of the entire Arctic sea ice and floating icebergs in the Northern Hemisphere would raise the global sea level by approximately 0.2 cm, according to Enigma's calculations. This is not to mention that the sea ice in the Arctic has never melted to such an extent. Data collected from the Panarctic Ice Ocean Modeling and Assimilation System (POMAS) from 1979 to 2021, which tracks the ice melting and reformation processes in the Arctic, shows a cyclical pattern. The overall volume of sea ice fluctuates from its highest point of approximately 28,000 km3 in April to its lowest point of around 11,500 km3 in September. Even when considering the combined sea ice in both the Arctic and Antarctic, with a maximum volume of about 27,000 km3 in September, the difference is still insignificant. Therefore, it can be concluded that due to the fact that the oceanic ice is already within the ocean itself, and the density difference between seawater and freshwater within the ice is negligible, the melting of sea ice, even in its entirety, has minimal impact on the global sea level. The sensational figures, such as the sea level rising by approximately 70 meters if all the ice melted, have the answer lies on land. If you were to look at the Earth's posterior, you would realize that at the southern pole of the planet, there is also an ice cap. In fact, it is even larger than the one at the northern pole. This is the Antarctic ice sheet, which differs from the Arctic sea ice. The majority of the ice in Antarctica is located on the continent itself, covering approximately 98% of the Antarctic continent's land area, which is around 2 million square kilometers. It is the largest ice mass you can find on Earth. This ice sheet is so enormous that it is almost enough to cover the entire surface area after the Himalayas. Unlike sea ice, which is typically only a few meters thick, the Antarctic ice sheet has an average thickness of over 2,000 meters and contains a total of 26.5 million cubic kilometers of ice, which is nearly 1,150,000 times the volume of the Arctic sea ice. In other words, if the Arctic ice sheet were to match the thickness of the Antarctic ice sheet, it would cover the entire surface of the Earth 32 times. At its thickest point, this ice sheet reaches nearly 4,900 meters, which is approximately 1.5 times the height of Mount Fansipan in the Indochinese range and 1.3 times the height of Mount Fuji in Japan. It should be noted that the Antarctic ice sheet is separate from the surrounding Southern Ocean. Approximately 1 cubic kilometer of ice weighs about 0.92 billion tons. Therefore, the Antarctic ice sheet, located at the south pole of the Earth, weighs nearly 24.4 million trillion tons, which is equivalent to the mass of 3.8 billion Great Pyramids of Giza or nearly 5 times the mass of the entire Earth's atmosphere. If we imagine the Earth as having only 100 liters of fresh water, about 61 liters of that would be accounted for by the Antarctic ice sheet. Scientific evidence suggests that the Antarctic ice sheet began forming approximately 35 million years ago, and parts of it are believed to have existed continuously for around 20 million years, which coincided with the time of the prehistoric giant shark, the megalodon. Returning to the main point, if the melting of sea ice is simply a transition of water state and does not affect sea level, the melting of land ice is a different story. It can be likened to when you drop an ice cube into a glass of water, the water level immediately rises. If the entire 26.5 million cubic kilometers of ice on the Antarctic continent were to melt, the global sea level would rise by about 72 meters. However, this is under the assumption that the entire ice mass is located on the land, which is not the case. While the East Antarctic ice sheet rests entirely on land, the West Antarctic ice sheet extends down into the water and can reach depths of over 2,500 meters below sea level. As a result, the ice volume in Antarctica is responsible for a sea level rise of about 58 to 61 meters, while an additional 7.2 meters can be found in the ice sheet covering the Greenland despite its seemingly suitable name for the development of cattle and other livestock. 80% of Greenland's surface area is covered by the white color of snow and ice. Although significantly smaller than the Antarctic ice sheet, the Greenland ice sheet is still approximately 5 times the size of Vietnam. It stretches for about 2,900 km in the north-south direction and around 1,100 km from east to west, with a total area of about 1.71 million square kilometers. The average thickness of the ice sheet is about 1,500 meters, roughly comparable to the highest point of Mount Fansipan, with some areas thicker and others thinner. The Greenland ice sheet is considerably younger than the Antarctic ice sheet. Deep drilling expeditions into the ice sheet have revealed that the entire southern region and much of northern Greenland were ice-free during the last interglacial period, approximately 125,000 years ago. At the current rate, only a small fraction of the Greenland ice sheet is projected to melt by the end of the 21st century, and it would take several millennia for the entire 2.85 million cubic kilometers of ice, equivalent to 8% of the planet's freshwater reserves, to melt. The melting ice contributes to the rising sea levels in both the Arctic Ocean and the North Atlantic, pushing the average sea level rise by about 7.2 meters. The remaining 0.5 meters of sea level rise comes from the melting of permanent snow and ice on high mountains and glaciers outside the Antarctic and Greenland, with an estimated total volume of around 170,000 cubic kilometers. The complete melting of all ice sheets and glaciers on Earth, combined with the natural expansion of water at higher temperatures, would indeed cause a global sea level rise of approximately 70 meters compared to the current level. This would be a catastrophic scenario, especially for coastal countries and billions of people living in coastal areas worldwide. Millions of square kilometers of land would be lost, according to the United Nations, and it is estimated that about 40% of the world's population, roughly 3.2 billion people, currently live within 100 kilometers of the coast. It's important to note that the scenario described above is a worst-case scenario and is unlikely to occur in the near future. From 1901 to 2018, the global average sea level has risen by approximately 15 to 25 centimeters, which corresponds to an average annual increase of about 1 to 2 millimeters. However, the rate of sea level rise is accelerating, and currently, it is increasing at a rate of about 3.7 millimeters per year. A 1995 report by the Intergovernmental Panel on Climate Change (IPCC) presented various scenarios for global sea level rise, predicting an additional increase of 50 centimeters by 2100. A more recent report in 2011 warned that if the Earth warms by an additional 5 degrees C, humans would have to contend with sea level rise ranging from 19 to 22 meters over the next 2,000 years. However, if global warming is limited to 1.5 degrees C, the projected sea level rise would be only 2 to 3 meters. It's important to discuss and share our thoughts on this topic. However, it's worth noting that the discussion should be based on scientific understanding and credible sources.